Alright, so let's look at C. So for the function y is equal to 2 sine 9x plus 180 degrees below, state the period, amplitude, and phase shift. So let me just use the full formula. In cases we are going to have a sine, um, let me call it this b, and then x plus c, um, and then okay, let's say c over d, and then minus, or let's say plus e. Let me just let's say c. This is the amplitude. This helps us find the period by dividing, what do? We divide 2 pi by the modulus of b. Then that, as long as you factorize this, x is of one coefficient, the phase shift becomes negative of c, and then this is the vertical shift. So let's try to apply that to what we have. So in our question we have y is equal to 2 sine of 9x plus 180 degrees. So let's factorize what we just have, x. So if we pull out the 9, we're going to remain with x. And then if you pull out 9 from 18, that's like 20, right? From 180. So 29 times 2 is 180. That's 18, yeah, 180. So that's what we have. So therefore, the period, which is the first thing, this is the first part 2 is the amplitude. This helps us find the period. Remember I said 2 pi over that 9, and then phase shift, this is the phase shift, it just changes the sign. So phase shift becomes negative 20 degrees. Now 2 pi over 9 is something interesting. Think of 360 instead, so that we try to divide, we see what we can have. And well, this is what it is in degree in radians. Now we want to convert that to degrees. We see how do you convert to degrees. Of course, 2 pi over 9 multiply by 180 over pi, right? So 2 times 180 is 360 over 9. Now 9 divided into 36 is how many times? Of course I know 9 into 27 is like 3 times. Now if I was to add a 9 to 27, that gives us a 56, which is an extra 4, making it 4. So it actually gives us 40 degrees. Quite interesting, right? So this is actually equal to 40 degrees. So it implies a full evolution of the function from this point. That point should be within 40 degrees. So let's try to sketch now. So we want to sketch from negative 20 all the way up to 100. Okay, so working with degrees. So 0. So remember that everything is supposed to be done within 40. So we're going to do a trick. Since we've got 40, how many 40s do we have in 100? That's 2, right? So let's do 2 full curves. Now don't forget that the amplitude is 2. The good part is this is a positive sine graph. The sine graph behaves this way. So we need to draw 2 first of all. So 1. Let's make it a bit shorter so that it tells us 1, 2. So if I remove this part, we've already done 2. So this is 40, that is 80. So that's what I mean. That's what we mean when you say amplitude, or when we say what? When we say the period within 40 degrees, a complete revolution of a curve should be done. Okay, so again within another 40 it's done. Now we're going up to 100, so we can do an extra half. We can just do half of the graph like this, and then that's where 100 is. And then on the other side, by the way, if you're having issues understanding what I'm doing here and you want to get more detailed, there's a video where we've talked about, it's like over 1 hour 30 minutes for just sketching. Check it out. It's available for free on our YouTube channel. So all trigonometric function sketching Transcended Institute, you find it on YouTube. So on the other side we're going up to 20, so again that's just half of the period, so it will just be like that, and then that's negative 20. Now the amplitude is what determines the maximum and the minimum point. So since amplitude is a 2, I say 2, and then this is a negative 2. Now some of you are wondering, what about the phase shift? So the phase shift is a negative 20, so it will move to the left by negative 20. So the graph, you can imagine every part moves by 20 degrees, and 20 is half of a period, so it's gonna move, it's gonna be interesting. So basically, in short, things will just change. So to make things easier for yourself, just move this 0 part by negative 20, so it's going to start from that point. Okay, and so if I sketch that below, it's going to be something like this. 1, so let me just do this, be like 1. So I have to draw a line for me to make sense of this. So that something like, so the 80 part, so this is negative 20, that's where the graph has now started from. This is now at 0, so this is 40, and then this is 80, and then that's going to end now at 100. So you've seen how it has changed. So if you want to do it a slower way, this is a faster way. If you want to do it a bit slow, you can actually move each point, drawing it by moving it to the left by a magnitude of 20 degrees. That's what the phase shift does to the graph. Okay, this was just for demonstration's sake, and if you want to do it more accurately, well, you're free to do that. So so 1, 2, if you can do something like 1, 2, and then 1, 2, and then 1, 2, and then you draw a line. So we said it was going to start on negative 20. This point had moved because of the phase shift, so that implies the 0 will be at 20 like that, and then this is negative 20. So half of the graph, because the period was 40, will be 20. So this gives us 20, right? Negative 20, 0, and then 20, 40, 80, and 100. That's 2. This is negative 2. So all the parts have been indicated: the amplitude, the period, and the phase shift. You've seen their effects on the graph. If our period was 180, the graph would have been like this from 0 to 80. So that's what the period does to the graph. I just need to emphasize on that.